So ladies and gentlemen, we're going to look at the boat problem. In 2003, a family bought a boat for $4,000. The boat depreciates or loses a rate at 7% annually. In 2006, a person offers to buy the boat for $3,000. Should the family sell the boat? First of all, is this a decay or a growth problem? Decay. The price of the boat depreciates, loses value. So we know it is, I'm going to call it P, you could say A, times 1 minus R to the T. Okay? So our initial cost of the boat was $4,000. It is going down at a rate of what? 7%. How do we change that into a decimal? Yes, ma'am. 0.07. I saw a lot of people's papers said 0.7. Be careful of that. And we want to know after how many years? 3, because between 2003 and 2006 is 3 years. Simply put it in your calculator. Remember, ladies and gentlemen, you can't multiply first and then take the exponent. You've got to take the exponent first and then multiply it. Order of operations. So we get $3,217.43. Should he sell the boat for $3,000? Why? Should he sell the boat for $3,000? Jeff says no. Why no? If he sells it for $3,000, how much money is he losing on the boat? And 43 cents. Okay? You don't want to. $217.43 is a lot of money. All right. Okay. So I found the difference between these two, and found that he's going to lose $217.43. Is that the difference between $3,000 and $3,217.43? All right. Stupid computer. All right. So, ladies and gentlemen, let's look at this interest problem. Okay. So in this, we have this formula that for some reason doesn't show up on a copy. Okay. How much money did this employee put in the savings account? Who knows? How much money did she originally put in the savings account? Yeah. Nobody has the answer to this? Okay. We know A is the amount of interest earned, so that's what we want to find. P is the initial amount. R is the annual rate. N is the number of times per year it's compounded. T is the time in years. Okay, so we're going to state what each of these things are. Okay, so if an employee earns $35,000 a year and she deposits 10% of the money into a savings account that earns 4% annual interest compounded yearly, after 2 years, how much more money does she have than if she had not put her money into the account? Okay, so my first question is, what is her initial amount? How much money did she put in the savings account? Nobody knows. How much money did she earn? $35,000. How much money does it say percent-wise she put in the account? 10. So what is 10% of that? Yes. What is the rate that the savings account earns? 0.04 or 4%. How often is the account compounded, or the interest compounded? Once a year. How many years are we looking at? 2. So we should be able to put this all into that equation. 3,500 times 1 plus 0.04, because 0.04 divided by 1 is the same thing. 1 times 2 gives me 2. So when I put that in there, she has $3,785.60. That's how much money she has. How much interest did she earn? How would I figure that out? This is how much money she has. How much interest was earned? And how would I figure that out? Subtract from $3,500 because that's how much money she put in there. So how much money did she get out of interest? Okay, she got $285.60. So that's how much money she earned out of interest. Questions? Okay, let's move on to the next page. Antique car values. So most car values go down. Antique cars do not, though. They go what? Up. Okay. So is this going to be growth or decay? Growth. Okay. So the owner of a 1953 Hudson Hornet convertible sold a car at an auction. The owner bought it in 1984 when its value was $11,000. The value of the car increased at a rate of 6.9% per year. Write a function that models the value of the car over time. The auction took place in 2004. What was the approximate value of the car at the time of the new auction in 2004? So what is A? What's the initial cost? $11,000. What is the rate? 6.9%, so we change it to 0.069. And what is the time? From 1984 to 2004 is how many years? 20. So then we just plug it in. And we get 41,777.92. That's pretty good markup of money. Questions about this problem? You guys are all writing this down if you got it wrong? You're fixing it? Okay. Let's look at video games. Okay. A person trying to beat a certain level of video game gets 20% faster each time he does the same level. It took him 3 hours to complete the first level. How long did it take him to complete his 5th attempt? Okay, so first of all, we know that this is what? Is this going to be, is the time going to go up or is the time going to go down? Down. So it's decay. Okay, so what did we start with? How many hours did we start with? So P gives me 3. What is the rate? What's the rate that he's getting faster? 20% or 0.2? And what is the time? That's kind of weird. What? 3 hours is the, but that's also the time that he started. 5, because it's his 5th attempt. I know it sounds weird, but if we're trying to figure out the number of hours, we're going to have to use his attempts as time. So we take 3 times 1 minus 0.2 to the 5, and we get approximately 0.98304 hours. What does that mean? How would I figure out how many minutes that was? What would I do? Times it by what? 60, because it's how many minutes are in an hour. And this is going to give me the number of minutes, which is 58.98 minutes. So I times it by 60 because I know how much this is of an hour, and if I want to find how many minutes it is. Okay, let's move on to the guitar problem. Any questions about this one before I move on? Can't read your minds, guys, so if you have a question, I don't know. All right, then. Let's move on to the guitar problem. Okay, this one is a little weird. It tells us that the distance between the nut and the first guitar fret is this equation. And we want to find the 12th and the 13th, which we know is half as long as this. So we're going to plug in 1 for F to figure out how much the difference between the nut and the first one is. And we get 1.431 approximately. And then how am I going to figure out between the 12th and the 13th if it's half as long? Anybody? If it's half as long as this, how do I figure that out? Am I adding, subtracting, multiplying, dividing? I heard it. Say it again. Dividing by 2. You take half of it. We get 0.716 of an inch. Anybody have a question about this problem? Okay, move on to the next one. Okay, this one's really crazy. And this one's going to be really relevant to you guys when you start talking about colleges. Okay, MSU told everybody that they were only going to increase tuition by 7.1% each year, but in actuality they increased tuition by 9.4%. So some of you, I showed you how to do this problem incorrectly, because do you pay tuition for college all at once for all 4 years? You have to pay it when? Each year, right? So we're going to take this and we're going to set up 2 problems. The tuition rate is increasing. And we've got, that's what they said, and this is what it was actually. But we have to find it for each year and then add it up. So I'm plugging in for T, I'm plugging in 0, 1, 2, and 3 to find for 4 years. So if I plug in 0, I get 11,670. If I plug in 1, I get 12,498 and 57 cents. For the second year, it's going to cost, at the end of my second year, it's going to cost $13,385.96. And the end of my third year, it's going to cost $14,336.37. So now what we're going to do is we're going to add all this up, and we find that in 4 years, it's going to cost me $51,891.50 to go to school. But that's if they told me the truth, which they didn't. So now we're going to plug in T for this problem. 0, 1, 2, and 3. So the first year is the same, because we started out with $11,670. But after the first year, it costs $12,766.98. The second year, it costs $13,967.08, or 7 cents, excuse me. And in the third year, it costs $15,279.98. Well, when I add these all up together, I get $53,684.04. What's the difference between these two numbers? $1,792.59. Okay, so when I signed up to go to MSU, this is not me, if somebody signed up to go to MSU, thinking they're going to pay this much money for a 4-year degree, ended up paying this much money for a 4-year degree. That means that's $1,792.59 more that you ended up paying. Would you be upset? What can you buy for $1,792.59? You could put a down payment on a car. What that means is you save all your money. You think you're going to pay that much, so then you save more to put that down payment on the car. It ends up costing more than that. All of a sudden, that means when you graduate from college, the money you saved to buy a car is gone. That means you're out of a car. I mean, if you think about it that way, that means you can't get some jobs that you might want. because you need a car that can travel farther away. That's costing a lot.